All right, so we're going to take a look at writing and evaluating exponential functions from a graph. So we looked at table, where you insert the table in here. Now we're going to have a graph. There's only one additional step, which is you just got to get the coordinates in order to input them. So again, this is going to be the Desmos version. Unlike the last video that I forgot, I'm going to remember right off the bat. All right, so here's a graph showing the amount. So they've labeled the coordinates for you, but normally you'd have to go get them. So how would I make a graph A table? All I would need to do is look at coordinates X and then Y, but they've already given them to you. So let's create a table. It says input the coordinates into Desmos, click plus to create table. So I click the plus. All right, I'm gonna go ahead and put in the table. All right, and at 0, it's 400. At 1, it's 240. At 2, it's 144. And then at 3, it's 86.4. So again, if they don't label the coordinates for you, you just go read your X and then your Y. So remember, your coordinates are always made out of your X and Y, so you can put them in a table. All right, so I've put in my table. Type the equation for the exponential function. If you don't remember what that is, you're going to go right into your formula sheet, right? And it's on the bottom left is what it looks like. Y equals ABX. So we're going to go ahead and type that in real quick. So Y equals A parentheses B shift 6 to the X power. All right, there's an error, a triangle. That's because there's two things that you need to do. So what are the two things you need to change? Oops, I did not mean to do that, guys. My bad. What are the two things that I need to change in order for the calculator to recognize what you're doing? Well, first you have to tell it, hey calculator, I want you to look at this table and give me the answer. So you got to use what the table is using. Sometimes this does change, so please be careful. Sometimes it's X2, sometimes X3. So right now it's X1, and Y1, so which means everywhere I see an X or a Y, I'm just going to go ahead and type in a 1. And then the second thing that I need to change is the equal sign. It needs to be a squiggly line. You can do shift squiggly line, which is right underneath the escape, or you can come right here, click ABC, and there's your squiggly line. As soon as you do that, look what happens. They tell you your start is 400 and it's changing by multiplying by 0.6. All right, so type the equation with A and B that you found in this step. So we're going to retype this equation, okay, but with A and B. So just the regular equation with an equal sign. So my A, according to this, is what? 400. So I'm going to replace this with 400. My B is equal to what? 0.6. So I'm going to replace it with 0.6, and voila, there is a graph. All right, so now I have everything input into Desmos. Whatever the questions are, I can answer. So let's take a look at the questions. Number 1, what is the y-intercept? Well, I could see that right here. What's the y-intercept? 400. What does it mean in context? All right, so we have to see what's happening. The amount of medicine in a person's body at different times, measured in hours after taking the medicine. So at 0 hours, hours after taking some medicine, when no time has passed, right? Right when they took the medicine, when nothing has happened, there was 400 mgs. So what does this mean? They were given 400 mgs of medicine. So again, those are like 3 different sentences I said. The person was given 400 mgs of medicine when no time was passed. At time is equal to 0, there was 400 mgs of medicine in the person's body, anything like that. But we can write, for this, the shortest sentence that I just said was, so 400 is my y-intercept. It means the person, in fact, had 400 mg of meds in body. All right. Again, 1,000 different ways that you can say that. We really need to get used to just writing the whole sentence out. All right. Number 2, how can you tell from the graph what B is? Okay. So how do I find B? How do I find this 0.6? That's the question. So remember, from a graph, you're supposed to take the second one, your second Y value divided by the first Y value. So my second Y value is 240 divided by my first one, which is 400. Now, did I have to use 240 and 400? No. As long as they're sequential, so you see how this goes 1, 2, I can do 144 minus 240. It's really the second one minus the first. I can do 86.4 minus 144, because if it's an exponential function, every time it changes, it's going to change by the same ratio or factor, and at this point it's 0.6. So we're going to double check that to make sure we have 0.6. So we're going to do 240 divided by 400, and it's 0.6. Now look, I didn't have to choose those two. Let's say I chose 86.4. I have to choose the one before it. So it'll be 86.4 divided by 144. And it'll give me the exact same thing because it does not matter which ones you choose as long as you choose them in order. The second divided by the first. So when I say y2 divided by y1, I don't really necessarily mean the second in order, but just the second y divided by the first y. All right, so there we go. All right, what is the equation of the graph? And we can see the equation of the graph is right here. So that's going to be, do I have to write it in any special way? No, I don't. So the equation is going to be y equals 400 times 0.6 raised to the x. Now, these two questions actually led you to do that by hand, but I'm also showing you how to do by calculator. So by hand, remember 400 is what? My a. So let me remind you again. So y equals a, b, x. What is my a? My a is my y-intercept. If there's no number, where? Over here. If there is a number here, it's going to be a plus that number. So my y-intercept. B is my growth. How do I know if something is growing? It's greater than 1. Or my decay. How do I know if something is decaying? If it's between 0 and 1. And then finally, x is my time. Okay, so we're speaking the same exact equation over and over and over again, just different ways to represent the question. So my start, my y-intercept, my start is A, so that's 400. And how is it now? Is this growth or decay? It's decay. How do you know? Because it's less than 1, greater than 0. And also from the graph, what's happening? It's going down. So of course it's decaying because the graph is decreasing. Once you know it's an exponential function, you can say definitively it's decay. All right, complete the following coordinates. Okay, so I want to know at 4, what is my y value? When x is 4, what is my y value? All right, so since we already have everything right here, I can come right here, make this a table, or I can look on the graph, but ain't nobody got time for that. And then just click 4. My y value is 51.86, 51.86. What's my y value at 6? So instead of 4, I'm going to hit 6. It's 18.62, 18.6624. Now, notice I'm putting the decimals. Why am I putting the decimals? Because in the last video, we didn't put the decimals because the amount of mg medicine a person, as you can see right here, can be in decimals. So we can write this as the answer. All right, so I've done questions 1 through 4. Go ahead and pause the video. You're going to do 5 through 9. All right, now that you've done questions 5 through 9, I'm just going to give you a hint here, but I really want you to think through everything else. I'm going to do one of these. I'm going to do question 11. Select all the points that lie on this equation. So since this is the Desmos version of what we're doing, here's my equation. I'm going to put that right up in the calculator, shift 6, and then x. Oops. And please make sure that it is typing exactly what you intend on it to type. All right, so double check that's what it is. All right, so these are coordinates. So I want coordinates. And if I want coordinates, I need to make this a table. If I do this, I'm inserting a table. So I want to do the gear, hit table, and then I want to look for the coordinates. So I'm going to type exactly in this order and then look. So there's 0, enter 0.5, 1, 3, 2, 3. All right, so I'm typing in order all the x values. So remember, this is x and then this is y, right? So is 0, 3 a solution? Yes. Why? Because it's in this table, because this is talking about this equation right here. So select all the points. We're just going to circle them. So this is a solution. About 0.5. Here we have 2.449. Is that there? 3 divided by 2? I don't know. Let's look at that. 3 divided by 2 is 1.5. But if you don't know, you're going to look. So is 2.449 the same as 1.5? No. So that's not a solution. What about 1, 2? Yep. 1, 2 is right there. What about 3.5? I forgot to put 3.5, so let's go ahead and do that. I misread it. 3.5, right? 3 over 2. And it says there should be 2. Nope, that's not a solution. What about 2? Says it's 1.43. Let's go ahead and see what 4 divided by 3 is. 1.333, and that's what it is here, 1.3333 repeated. Okay, so that is a solution. So this one's a solution as well. And then lastly, 3.8. Nope, it's 3 and 0.88888. All right, so that's how I found my solution. So you should be able to do that one. This one is which value can you add? So here's my hint. You know this is an exponential function. Why? Because it says it in the question. It's an exponential function. All right, so I need you to find what is the equation, because that's what we need for Desmos, right? We need to put in the equation. Find the equation, and you can use the calculator or by hand. If you need the calculator, this is what you're doing right here. And just remember, this is X and this is Y. Find the equation, put it in here, and then look at the value for 3 and write it right there. Let's practice.